Okay. Let's continue. Continue. Okay. In this chapter, I will introduce something about types and the definition of variables and the introduction to LED program. And as you know, last course, we see the variables to PLC. It's about this one. The length is maybe a bit, or a byte, or a word, or a double word. So if we defined a variables, you can use this method, such as aim 3.4. This means what? This means the variables is in aim area. Aim is the memory area. Aim aim. 3 is the address of a byte. The byte address is 3. And 4 is the bit address. It's a bit address. So we can see AM 3.4 is this one. This one. This is 3 bytes. 3 bytes. The 3 bytes. Okay. So we can see if the variables is in array in various in the memory V, and the V be 100, it means these variables. The 100 is a byte address. And this one is means what? Is with the variables is in memory V. And the variables, the length of variables is what? Is a word. So we can see W100, including what? Including VB100 and VB101. So we can see VW100 is including VB100 and VB101. So VD100, it's including VB100, VB101, VB102, and VB103. So we can see this is the variables about the PLC. And the V or I or Q or M or S or L and the SM, it's the memory areas. So we can see the I is means what? It means process imaging input. It means the variables is input signal. So we can see I 0.00. It's an input signal. and they signal only two states, 0 or 1, 0 or 1, 0 or 1. So we can see this. And Q is output signal, and such as Q1.3. It means this variables is the output signal, and this output signal, the byte size is 1, and the bit size is 3. So this is about the variables. And we can see the operation of the programmer controller is relatively simple. The input and output system is physical connected to the field device, such as encountered in the machine or are used in the control of the process. This field device may be discrete or analog inputs, outputs. And we can see that this field device may be a discrete or analog input output. Discrete, such as I 0.1 or Q 1.3. In these variables, it's a discrete input or output signal, such as a limit switch on or off, switch limit. It means 1 or 0, pressure transducer, push buttons, motor starters, and so on. The input interface provide the connect between the CPU and the information provided input and the controllable device output. During its operation, the CPU completes 3 processes. It's read. It means accept or input data from the field device via the input interface. The second is it executes. It means performing the controller program stored in the memory system. And the third is it writes or updating or output device via the output interface. Its process of sequentially reading the input, executing the programming in memory, and updating the output is known scanning. It's the scanning of the PLC CPU in PLC CPU. Scanning including reading, executing, writing. So how the PLC to running the program? This is the process of the running. It's including reading, executing, and writing. And we can see V is what? V is the variable's memory. You can see use V memory to store intermediate results of the operation being performed by the control logic and in your program. You can also use V memory to store other data pertaining to your process or task. You can access the V memory area in bits, bytes, or double words, such as V 10.2. What means 10.2? It means this variables is in V area, and the byte size is 10, and the bit size is 2, such as VB 16, VW 100, such as, and M is a flag memory. You can use the flag memory area as an internal control relays to store the intermediate status of the operation or other control information. You can access the flag memory area in bits, bytes, words, or double words, such as MB0, such as MB0, such as MW11, such as MD20. And T is a timer memory. The CPU provides timer that count increments of the time in resolutions. Time-based increase or 1 microsecond, 10 microsecond or 100 second microsecond. Two variables are accessed with timer. Its current value, and the timer bit. If its bit is set or cleared with the result of comparing the current and the preset value. The preset value is entered as a part of the time instruction, such as this one, this one. We can draw a timer. It's timer 37, and this is the input signal 0.0, and this is enable node, and this one is what? This one is the It means what? It means preset value. And this is what? This is the timer type. Timer type is TOM. And this is what? This is sorry, I will translate it to English. Resolution radio. Resolution radio. This one. It means it account by 1 microsecond or 10 microsecond or 100 microsecond. For example, we can see this one. Maybe this is 10. This is 10. It means what? It means if I 0.00 equal 1 continue equal 1, the time of I 0 the time of I 0.00 equal 1 is more than 10 times of 100 microsecond. It means what? If t time more or equal 1 second, because 10 multi 100 ms equal what? Equal 1 second. 1 second. So we can see if this one equal 1, the time is more than 1 second. The time 737 will equal 1. Will equal 1. So this is a time memory. This is a time memory. And C memory. C memory is a counter memory. It's similar to time memory. And the AC memory, accumulators. And the SM memory, it means special memory. And the L memory, means local memory area. It's only used in local program or subrouting program. You can see the CPU provide 64 L memory bytes for each POU in a local memory stack. A POU is associated L memory address are accessible only by currently executed POU. POU is what? Only in main or subrouting or interruption routing. When you use interruption routing and the subroutings, the L memory stack is used to preserve the L memory values or a POU that temporarily suspended the execution so another POU can execute. The suspended POU can then resume execution when L memory value that existed prior to giving execution control to another POU. And AI memory. AI memory means what? Means analog input. And the AQ memory means analog output. So we can see this is an example of the ladder program of PLC. And we can see this is a hard-rated system. And this one we can see is a button. If I push this button, this note is conductor. It's conductor. Break over. It means break over. It means break over. And this one, if we push this one, and it will conductor. And this one, it will push it, and it will conductor. If this break over, if this break over or this break over and this break over, then this light is on. This light is on. This light is on. So we can see this is the hard write, and this is a PLC program. It's similar. And this equal what? This equal this one. It means what? It means if LS1 equal 1, then this what? This can break over. This can break over. And LS2 equal 1. This break over. If this break over, then SOL equal what? Equal 1. You know? This is a hard write, and this is a PLC program. And this is equal this program. And this is equal this program. And how to program in PLC? The program language about PLC is including 5 language. The first language is what? The first language is a sequential function chart. The second language of PLC is what? Is the ladder diagram. It's the main program. It's the main program or main language about PLC. And the third is what? Is a function block diagram. And the fourth is what? The fourth is instruction list. Instruction list. It's such as it's similar to what? Similar to C. And the last one is what? Is structured text. The programmer editor contains the programmer logic and the variables table, where you can assign assembly names and or for temporary program variables, subroutines, and interrupt routines appeared as tables at the top of the program header window. Click the tables to move between the subroutine, interrupts, and the main program. Step 3, you have stored the software. Step 3, then provide a string editor for creating your program. The ladder logic and the statements list and the function block diagram. It's a step 3 about the language of step 3 you have installed last course. This is the step 3 software. And in this software, we click the program block. We can see this is what? This is the LED program. LED program. And this one is it means ladder program. And this is what? This is what? This is the instruction list.语句表 in Chinese 语句表 instruction list 这个叫梯形图 in Chinese 梯形图 So this ladder program is a instruction list in this PPT, we can see the ladder editor display the program is a graphical representation similar to electrical writing diagrams. The LAD program emulated the flow of the electrical current from a power source through a series to logical input conditions. That is a turn-enable logical output conditions. A ladder program including a left powering. This is the left powering. That is energized. Connected that are closed alone. Energy to flow through them to the next element and contacts that are open block that energy flow. The logical is separated into network. This is the network 1 and this is a network 2. The logical is separated into network. The program executed one network at a time from the left to right. Executes the program is from left to right and from up to down. from up to down, top to top, top to bottoms, top to bottoms. And this is a function block. This is a function block, the PLC language. And this is what? This is sequential function chart. Function chart. This is what? This is what? This is means instruction list. Instruction list. This is what? It's a ladder program. Ladder program. So I will give you something about the program of a PLC, the structure, and this part, and this part, and this part. You can see this part from the file, from one file, from this file. This is what file. This is the from the Siemens company. It's about the A7200 smart PLC, and it including what? Including the product overview, getting started, installation, PLC concepts, and programming concepts, PLC device configuration, web server, programming instructions, communication, libraries, debugging and troubleshooting, and PID loops and tuning. So we can see this one, programming concepts, programming concept. So you can read after my course. You can read this file. You can read this file, and to learn something I have not introduced to you. So you can see this one. You can see this one. Is what is the file? The file, PDF file, A7200 smart system manual in English editor, in English voice. So we can see the elements of the user program. A program organization unit, such means POU, is composed of executable codes and commands. The executable codes consist of a main program. So we can see this one. main program, and any subroutines or interrupt routines, subroutines and interrupt routines. The code is compared to download to CPU. You can use the program organization units, including what? Main program, subroutines, and interrupt routines. Interrupt routines. Main body of this use program contains the instructions that control your program applications. The CPU executed these instructions sequence once or sky cycle. It means sky cycle. Sky cycle. This one. What is a sky cycle? This one. I just introduced to you this one. It's the sky cycle. Sky cycle. It's including reading, executing, and writing. Subroutines are operation elements of your program, which are executed all in one code by the main program by a interrupt routines or by another subroutine. Subroutines are useful in cases where you want to execute a function repeatedly rather than rewrite the logical or each place in main program where you want the function to occur. You can write the logical ones in a subroutine and call the subroutines many things as needed during the main program. Subroutines provide several benefits. Using subroutine reduce the overall size of your program. Using subroutines decreases your scan time because you can have more the code out to the main program. The CPU evaluates the codes in main memory every sky cycle, whether the code executed or not, but the CPU evaluated the code in subroutine. Only when you call the subroutine, it does not evaluate the code during the sky in which the subroutines is not quoted. Using subroutines created code that are portable. You can isolate the code for a function is in a subroutine and then copy that subroutine into another program, which failed not to record. Interrupt routines are optional elements of your program that react the specific interrupt events. You design interrupt routines to handle a pre-divided interrupt events. Whenever the special events Of course, the CPU executed the interrupt routines. The interrupt routines are not called by your main program. You accessed a interrupt routine with interrupt elements, and the CPU executed the instruction in the interrupt routine only each uh, occurrence of the input elements. And we can see this one is what? This one is a main program. And this one is what? This one is a subroutine. This one is a subroutine. And this one is what? This one is interrupt routine. Interrupt routine. And then in this picture, and in this picture, we can see the sky process of the PLC, and uh, I will have a break, have a break, 10 minutes, 10 minutes, and after 10 minutes, I will go on. Okay? Can you hear me?
Yes,
Yes,
Laoshi.
teacher.
Have a break. Okay. 10 minutes.
Laoshi.
Okay. Okay, everyone. I will continue my course. Okay.
Okay,
And
teacher.
we can see this picture. And we can see this picture. And in this picture, we can see the PLC, the one sky cycle, The one sky cycle is including this one, read input, execution procedures, and processing communication request, perform CPU self-diagnosis, and the last one is the right output. And I will give you example. And in this example, uh, I will sorry. I will discuss example. Let me see. If a PLC program, is this one. I 1.1, and this one is I 1.2, and this is what? This is Q 2.2. 2.2. And this is a node. Its node is what? Is a Q 2.2. And this is, and I have introduced the logical relationship about these variables, and we can see if I 1.1 equal 1, if 1.1 equal 1, and this node will what? Will break over. It means this. It means is if I 1.1 equal 1, it means this node will break over. And if I 1.1 and 1 and I, this is end, and I 1.2 equal 0. So we can see if 1.2 I 1.2 equal 0, this node will what? Will break over, because this is a closed node, and this is an open node, and this is a closed node. So if 1.1 equal 1 and I 1.2 equal 0, then Q 2.2 equal what? Equal 1. So we can draw the the time series. The Q 2.2. So we can see in this term, because I 1.1 is 1 and I 1.2 is 0. So Q 2 and 2 is what? Is 1. You know? Is 1. And we can, from the scanning of the program, the first input is what? is a read input, such as its relative to I 1.1. 1.1. 1.1. From here we can see I 1.1 is 1. If we push the button, and when push the button, and when I push the button, so I will read the first step. The first step. The first step is what? Is read. Input. So we can see in this input imaging, input memory, or input image memory. This I 0 I and I 1.2 is what? When read input. This one is 1 and this one is 0. And this one is 0. This one is a 0. So the first step is a read input. And the second step is what? Second step is the executed. Executing. Executes. Executing what? Executing program. So we can see if we executing its program as I 1.1 is 1. So this note is its note is break over, and because I 102 is a 0, so this note is what? Is a break over. So Q 2.2 is what? It's equal 1. So second executing program. So Q 2.2 equal 1. And the third step is writing. Is writing. Is what? Is writing to what? Is writing to inputs, imaging memory, outputs, outputs, imaging memory. So we can see Q1 is 1. So we can see where right, where right. Write this one to what? To the device, to the device, such as a light, a light, a light. So we can see we push the button, this button, and the light is on. The light is on. And the second sky, I will read the input. I will read the input. If in this sky the input I 1.1 is what? Is to 0. It means I did not, I have not to push this button. But as Q 2.2 is 1, so this note is what? Is break over. So I when I 1.1 equal 0, when equal 0, but Q 2.2 equal 1 at last at shines light. Sorry, I will translate it to last sky. Last sky. Because Q 2.2 equal 1 at last sky. So then this note is what? Is break over. It's break over. And this one, because I 1.2 equals 0, equals 0. So from this Q 2.2 equal 1. You know, because last sky, the Q 2.2 equal 1. So in this sky, A sky, in this sky, when I 1.1 equal 0, but Q 2.2 can from here to be a 1. You know? Do you have some question about this? Because if I will introduce this by Chinese, I can say clear. But in English, I guess you have something question about this. Okay, if you did not have any question, I will go on. And in this chapter, I will go on to introduce the program, and the program including LED, LED, LED program, and another is a STL program, and how to convert LAD to STL, and I will introduction something about this. So I will give you some example, and this example is what is this. 0.1. This is Q00. This is a program of a LED program, and if I do this by STL, it means what? Is equal LB I 0.1 equal Q 0.0. This one and this one is equal. You know? So you can ask me some question. What is LD? What is LD? I mean this one. Means what one? This one. What is LD? Maybe we can to learn STL by a stack, by a logic stack. Do you know stack? It means a memory. Means a memory. Logical states of the variables, and we can see this in this stack. This is xe, x1, x2, and x3. If we executed this language LD x5, the stack will change to what? Will change to this x5, and the second is what? xe, x1, and the third is what? x2, and this one is what? x3. Do you know? And equal Q 0 to 0. It means it will copy the top level. This is the top level. The value in top level. It will copy the value of the top level to what? To Q0 0.00. Do you know? Do you have some questions? Do you have some questions? Okay,
No,
you didn't know. Okay, I will go on. You have some questions? So I will ask you, if we do this LD x 5 LD x 6 and equal Q 0 0, and when this program was executed, and Q 0.00 is what? This is what? This is what? Can you tell me? If we executed this program, Q 0.00 is what? Can you tell me? Can you tell me? This is a simple problem. It's a very simple problem. If you can't answer this question, and in the end of this course, the test, the examination, you will, it's impossible to pass it.
Can you say again this question?
So I didn't understand you 那个哎呀，你们能听得懂中文吗
对。
？Okay, I will say something about 中文。这个问题呢，已经是非常简单了。那么作为这个期末考呢，肯定是要比这个那个题目呢，肯定是要比这个难的很多。所以刚才我这样讲完以后呢，大家还不太理解，这件事情就很难了。这件事情就很难了。那么当然，如果我在讲的过程当中 ，if you have some questions， 那么你们可以随时向我提问 ，ask me。Do you know?
Yes, teacher.
Okay, I will say it again. Say it again. So I will include this. I will say it again. And I will use this. This point. Now I will say it again. I see this. This is a program of the ladder program. This is a ladder.
Should we understand ladder program?
Because we introduce to you the program of PLC, including what? Including ladder diagram. This is a type of the program. Do you know? And
Yes, Loshi.
Instruction list. This is a type of the program about PLC. Do you know? And this one, these two, you must to learn. You must to learn. This one, these two, you must to learn. You must to learn.
Laushi,
So I will give
later,
you uh, some question.
yeah, layer diagram we
有什么问题吗？
can make this easily, but we cannot calculation like I 0.0 equal 1. This method we cannot. So with this new one, so we need to learn first
Yeah.
this one.
Oh, okay. Yeah. Maybe I will introduce this again, and I will ask you again. So this is a ladder program. Ladder program. This is a variables I.
Open loop.
Yes, open loop. I or or I will use this one. Okay. 0 0, and this is Q 0.0, and this program equal what? Equal what? Equal
Laushi, we don't know.
LD. You know, this is equal. The same.
Input output 0 0.
等价的 equivalent equivalence equal. So we can see in this leg, it means what? It means if I 0.0 equal 1, then Q 0.0 equal what? Equal 1. You know? And this program we can use STL to do this. And STL, I want to know something about a stack. Logical stack. So we can see in the initial, this stack, this is a stack. Stack. Initial is what? Initial is one is x1, x2,
Memory store like
x3. When executed Okay, sorry, it's execute. Execute. Sorry, I mistake. I make a mistake. Execute. When execute. When execute what? Execute this one. This one. When this program, blue, this program B executes, this stack will change to what? Will change to what? Will change to what? When LD is means what? LD is means Lord. When this program is executes, the stack is changed to what? Can you tell me? It's changed to what? The top level.
Maybe I
The top
0.0
level
and
is what?
X1 I 0.0.
The top level is what? I 0.00. And the others where is what? Where
X1, X2.
go down. Where go down. Where go down. So it is X1, X2, X3. You know? And
Yes,
Yes,
teacher.
Laushi. So
this
this
program
means
means what?
load can be
It means to
stored in
copy.
memory. Right.
This one means
Okay, Laushi, we
copy.
understand now.
Copy the top. The top level variables to what? To Q 0 to 0. So we can see if we executed those Q 0.00 equal what? Equal what? Do you know? Q 0.00 equal what? Do you know?
I 0.0, teacher.
Equal I 0.00. Do you know? So
Yes, teacher.
another question is this. Another question is this. LD I 000 LD I 0.1 equal Q 0.00. And my question is, when we executed this program, Q 0.0 equal what? Can you tell me? LDI 0.00. LD 0.1 equal Q 0.00. And when we have executed this program, Q 0.00 equal what? Do you know? Equal what? Equal what? Can you tell me?
Teacher, maybe I 0.0 at first and second I 0.1.
Yes, yes. So it means because this one, because this. I will.
Lavshi, why we writing this value? Why we writing this directly LDI 0.0? Why we don't use value?
Because in this when we executed this one, executed this program, the stack will change to what? Will change
Change
to
it
what?
LD
Will change to
LD
I
0.0 LDI
0.0,
0.0.
and this is x1, x2, x3. And when executed this one, this will change it to what? Will change it to what? To
X
I.
I 0.1.
So Lavshi, to if we need to two out input, so two executes, two memory, right? Not only one.
Yeah, yeah. So it will change
And
it
0.
to 0,
I 0.0.
0, and this is what? Xe,
X1, X2.
x1, x2. Do you know? Do you know? And
Yes,
the
teacher.
first step we executed this one is this. And the second step we executed this one and it will change it to this. So we ask you, what is Q0 0.00? It means 0.0 equal to what? I 0 point what? 1. Because the top level, this, the top level. And this is means to copy the top level variables to Q 0.0. Do you know? Do you know?
Yes,
No,
teacher, we
Lavshi,
understand.
Lavshi, I don't understand.
Okay.
Can you explain again?
Actually, load
You
means
can
to copy the
understand.
top
So
level.
So always copy top
yes.
level, right?
Yeah.
Output. Okay,
Yeah.
Yeah.
okay, Lavshi, I got it.
Okay. Okay. So I will ask you another question. In this we can see this program. I 0.0 and I 0.1 and to what? To Q 0.0. And this one equal to what? And this one equal to what? This is ladder.
Diagram.
Ladder language about PLC. And if we use STL language, this is what? This is one. LD I 0.00 LD sorry, I will see something about another. LD I 0.1 ALD equal Q 0.0 and this one equal to this one. Well, I will explain this by the stack. So we can see this is a stack. This is a stack. And this is x1, x2, x3. If we do this one, LD I 0.0, this stack will change it to what?
I 0.0.
If we do this program, this stack
Analog.
change to what? Change it to I 0.0. And this one is what? X1, X2, X3. And when do this or executed this one, this stack will change it to what?
Actually, this one analog load, right? ALD.
The top level is value is what?
0.1.
0.1. And this is I 0.0.
0.0.
And this is what? X1, X2, and X3. And when we'll do this one, do ALD. ALD is means what? It means what?
Analog.
It means this. It means it will. This is end. This one and this one is end. The result is the top level, and another will go up, and another and the others will go up. So we can see if we do ALD and the stack will change to what?
It
Will
will
change
be
to what?
teacher.
Can you tell me?
SO.
The top is what? The
SO.
top is what? A.
X.
A it means end. Is end. So the top is what? Top is
Addition of
I 0.0
0.1 plus Cross.
And. It means end. It means end. L Q
0.0.
0000. Do you know? And this is what?
X1 teacher.
And this is what?
X1.
I0. Let's say I0 where this
X1, X2, X3. So when we executed this one, it will change to this. It will change to this. It will change to this. Change it to this. Do you know? Change it to this. So I will ask you, when we execute this one, Q 0.0 equal what?
It will
Equal
be
what?
I
You tell me.
0.1 into I 0.0.
I 0.1 and it means and I 0.0. So it means this one. This node is serial. You know? This two node is serial. So
Yes, teacher.
Q 0.0 if I 0.0 equal 1 and I 0.0 那个 1 equal 1 then what? Q 0.0 equal 1.
1.
Do you know? Do you
Yes,
know?
teacher.
So
okay.
we can see this this ALD. This means ALD. ALD is means we will do something about the L 0.00 and L 0.1.
2.1.
If this is not ALD, it's changed to OLD. If the OLD, it means what? It's not the it's not the end. It's not the end. It will change to what? O. Because it means this means end. This means end. And this means what? O. Do you know? O. Or it means what? It means this is I 0.1 and this. Do you know?
Parallel.
If the ALD change to OLD, you know? So this is what I will introduce something about you, but because the time is limit, So when this gas when after this gas, I will you will to do some reading. Reading what? Reading this one. This file I will give you. I have given you by Weixin. Do you have this file? Do you have this file? This file, do you have? Oh no, 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 I did not share. I did not share. Okay, share. Do you have this file?
No, Lordship.
Do you have this file? You have, right?
No. 没
呃，
有。
没有吗？我发过的，我很早第一节课就给你们发过了这个文件。我待会儿再发一次。I will send this file again. I will send this file again. And in this file, I will ask you to do something, to read something about the chapter 4, chapter 4,
Maybe we have.
and chapter 5. Chapter 4, chapter 5, and chapter 8. 5 or 4, 5, 8. 4, 5, 8. You must to reading. You must to read. You must to read this file. This is the homework. This is the homework. This is homework. Because haven't come to campus, come to your Yunnan University. So the next so this afternoon, I will I will go on 2 course, but as you not come here, so I will give you some homework to read. Do you know?
Okay, Lordship.
由
Which
于你
chapter?
们
4?
没有到学校，所以今天下午的后面的2节课，你们没办法做实验。Do you know? 那么你们就把这个文件里面的第4章、第5章，还有第8章的内容好好读一读，自学，然后我们下节课再讨论，下周一再讨论。Do you know?
好的。
Okay, Lordship.
Okay, teacher.
Okay.
Lordship, which chapter? Can you say again?
So
4?
4, 5,
Yeah.
8.
4, 5.
458. 458. It means PLC concepts, programming concepts, and program instructions. 458. 458. Do you know? You will read it as a homework. Do you know?